LSG is leader in lighting and electrical test instruments. Hello everyone, this is Daisy. Let me introduce to you the installation and use of the LSG-1890B LSG-1800A High Precision Rotation Luminaire Goniophotometer and LSG-1890BCCD LSG-1800A High Precision Rotation Luminaire Goniospectroradiometer. The following is the video catalog. 1. System installation. 2. System adjustment. 3. System calibration. 4. Measurement. Please check the packing list when you receive the shipment. There are 6 boxes for LSG-1890B or LSG-1890BCCD model. 1 box contains the base of the Goniophotometer. 1 box contains the turntable of the Goniophotometer. The spectroradiometer of the CCD model is also in the box of the Goniophotometer. 1 box contains the clamps. This is the C-gamma clamp. This is the B-beta clamp. This is the E27 holder. 1 box contains the cabinet. 1 box contains the AC power source. 1 box contains the DC power supply. There are 5 boxes if your model is LSG-1800A or LSG-1800A CCD. The only difference is that the Goniophotometer is already assembled and packed in 1 box. All the other small devices and accessories are contained in the boxes described above. Please carefully open all the boxes. Take out all the devices and accessories. There is also a plastic bag in the package that contains a CD, calibrate certificates, and guarantee cards. There is software, user manual, operation video and related standards in the CD. Open the back door of the cabinet. There is a wiring diagram on the door. Put the digital power meter, rotary actuator controller, DC power supply into the correct positions of the cabinet. LSG has different sizes of AC power sources. Small ones can be put inside of the cabinet too. But big ones need to put outside of the cabinet. Here is the power cord for the cabinet. Put it through this hole. There is a fan on the top of the cabinet. Plug the power cords of the fan, digital power meter, rotary actuator controller, AC, and DC power supply to the power strip inside of the cabinet. Connect the 4 wires to the 4 terminals on the back of the power meter according to the wiring diagram. Connect the communication cable to the communication box. Connect the output lines to the back of the DC power supply. Pay attention to the positive and negative poles. Connect the communication cable to the communication box. This is the AC power output lines. Connect the output of the AC power source to the cabinet. Connect the communication cable to the communication box. Connect the communication box to the computer using the USB cable. There is a taper sleeve on the top of the base of the Goniophotometer. The sleeve and the base are engraved with one same number. Make sure the numbers are in the same direction and fix the sleeve to the base using the screws. Open the dust cover of the turntable. There is the terminal bar under the dust cover. Lift the turntable using a forklift. There is also a terminal bar out of the taper sleeve. Make sure they are in the same direction. Put the turntable down on the base slowly. Protect the terminal bar of the sleeve and make sure it goes through the hole successfully. Verify the direction of the turntable. Make sure that the 6 screw holes correspond to the base one by one. Fix the turntable on the base using our screws and gaskets. Connect these 2 terminal bars. Put the dust cover to its original position. Move these 4 feet up. Then move the Goniophotometer to the correct position according to the darkroom drawing. Try to keep the sides parallel to the wall. The side with the word faces the photo detector. There are 4 terminals marked with numbers on the back of the cabinet. They are used to connect with the goniophotometer. These two terminals are connected to the power strip inside of the cabinet. It is used to power darkroom equipment, including the goniophotometer, photodetector, spectroradiometer. Then you can control the power supply of the entire system on the cabinet. Connect the grounding terminal to the ground. This is the photodetector and its holder. Assemble it and put it to the correct position according to the darkroom drawing. There is a 1-to-2 communication cable for the goniophotometer. Connect the RS-485 port at one end to the goniophotometer. The other end splits in two. Connect the end with RS-485 port to the communication box inside of the cabinet. Connect the other end to the rotary actuator controller inside of the cabinet. If there is only one photodetector in your system, connect it to trigger, N, with the signal line. There are 3 wires connected to the photodetector. The signal line is from the goniophotometer. The communication cable is connected to the communication box inside of the cabinet. The last one is the power adapter. Put the spectroradiometer and its holder at the correct position according to the drawing. There are 3 wires need to be connected for the spectroradiometer. The RS-485 communication cable is connected to the communication box inside of the cabinet. The power adapter. The optical fiber. The other end of the optical fiber needs to be assembled with the sleeves. Please assemble as shown in the figure. Then fix it on the fiber holder. Please note that the fiber should not be bent too much or it will break. Turn on the system. And make sure that all the devices in the system are turned on. Copy all the files on the CD to the computer. Double-click to install the goniophotometer software. Double-click to install the driver for the communication box. Copy the APK file to your Android phone and install it. Turn on the Bluetooth function of the phone. Open the app. Click here to connect the goniophotometer. The app is used to rotate the goniophotometer, but it can't run a measurement. The function of the app is the same with the rotary actuator control panel of the software. Let's take software operations as an example. When you run the software for the first time, it will automatically enter the configuration interface. Choose the correct models for all the devices. The goniophotometer, the near-field photodetector, the far-field photodetector, the near-field spectroradiometer, the far-field spectroradiometer, the AC power source, the DC power source, the digital power meter. Click Auto Search Communication Port when all are selected correctly. If you only have one photodetector and one spectroradiometer in the darkroom, the default is near field. This operation video takes one photodetector and one spectroradiometer as an example. After successful configuration, a window to save the file will pop up. Please choose the path of the file, and input the file name. This file is used to save all the test history. This arm of the goniophotometer is the auxiliary arm. Remove it. The other one is the main arm. There is the switch for the laser on the back of the main arm. Turn it on. Then you can see one laser coming out in front of the main arm. There is a cross laser device inside of this box. Take out the cross laser and its battery. Load the battery into the device. Turn this switch to unlock position. Then the cross laser will be turned on. There are the switches for the vertical laser and horizontal laser on the top of the device. Turn on the horizontal laser. Adjust the height of the laser to the height of the goniophotometer and the center height of the holes in the partitions. Open the software. Click Type Convert to show the C-gamma angle. Click Rotary Actuator Control Panel. Choose Illuminometer for near field. Click this button to make it rotate continuously. Then you can see the laser spot moving on the darkroom wall. Now you need to rotate the screws to adjust the height of the 4 feet of the goniophotometer. Make sure the laser spot and the horizontal laser are completely coincident within the range of 360 degrees. All the 4 feet need to touch the ground firmly after the adjustment. Sufficient patience is required to adjust this step. Click the stop button to stop the rotating after the adjustment. Turn the screw up to secure the feet. Choose Illuminometer for near field. Input 0 here. Click any one of these 2 buttons to rotate the goniophotometer. The main arm will stop at 0 degree position when it stops rotating. The laser should goes through the center of hole of the partition. If you have more than one partition in your darkroom, just refer to the last one. If the laser is not in the center, please input a small number and choose a direction to rotate according to the actual situation. Make sure the laser goes through the center of the hole. Then this is the real 0 degree position of the photo detector. Click Set to 0. The password is Listen Group. It displays 0 at gamma angle after setting 0 successfully. Screw down the sleeve of the FAR detector. Install the mirror tool. Now the gamma angle of the goniophotometer is still at 0 degree position. Please adjust the position of the detector holder, the height and direction of the detector. Make sure that the laser from the main arm of the goniophotometer goes to the center of the mirror tool, and the reflected laser goes to its original position. This step also needs patience. All the screws should be tightened after the adjustment. Then fix the base of the detector holder to the ground using the screws. You may need to readjust the direction of the detector slightly to make sure that it is still in the correct direction. After the final adjustment, remove the mirror tool and install the sleeve back. The holder of the spectroradiometer doesn't need to be in a precise position. Just put it at the corresponding corner according to the drawing. And then fix the base of the holder to the ground. Install the mirror tool on the sleeve of the optical fiber. Rotate the gamma angle on the software to aim the laser at the mirror tool. Now you need to adjust the gamma angle, the height and direction of the sleeve. Make sure that the laser from the main arm of the goniophotometer goes to the center of the mirror tool, and the reflected laser goes to the original position. All the screws should be tightened after the adjustment. After the adjustment, remove the mirror tool. Keep the optical fiber always fixed in the sleeve. Now the laser goes to the optical fiber. This position is the 0 degree position for the spectroradiometer. Choose colorimeter for near field. Then click Set to 0. The password is Listen Group. It displays 0 at gamma angle after setting 0 successfully. Install the cross laser on the triangular metal support. Check the drawing to confirm which side of the wall to install the cross laser on. Choose Illuminometer for near field. Rotate the gamma angle to 90 degree or 270 degree position according to actual situation. Make sure the laser goes to the position of the cross laser. Turn on the cross laser. Put the triangular metal support on the wall. Adjust the position of the support, the direction of the cross laser. Make sure that the center of the cross laser is completely coincident with the laser from the main arm of the goniophotometer. It should also be noted that the support of the cross laser is in a horizontal state. If not, the device will sound an alarm. Use screws to fix the support to the wall after the adjustment. You may need to fine-tune the position of cross laser to make sure that it is still in correct direction. All the screws should be tightened after the adjustment. Rotate the gamma angle back to 0 degree position. The cross laser beam hit the opposite wall. Make a permanent mark here. The installation and adjustment are finished. Turn off the power of the system. Clean up the room. The equipment can be covered to avoid dust entering when cleaning. We need to calibrate the system before using it. First, calibrate the photo detector. Choose Illuminometer for near field. Rotate the gamma angle to 0 degree position. Turn on the cross laser and make sure that the laser hit the correct direction. Take out the standard lamp. Assemble it as shown in the figure. Also install the mirror tool. This is the rod for calibration. Insert it in the center of the goniophotometer. Remove the top section of the rod. Install the standard lamp holder on the top of the rod. We use 4 wire connections. Use the wires to short the red and yellow terminals, and short the blue and black terminals here. Connect the power wires to the red and blue terminals. Then need to adjust the height of the standard lamp, the direction of the standard lamp. Make sure that the cross laser hit the center of the mirror, and the reflected horizontal and vertical laser coincident with the original horizontal and vertical laser. Remove the mirror tool. Remove the cover of the standard lamp. Turn off the cross laser. Our standard lamps are constant current DC lamps. Turn the AC-DC switch on the cabinet to DC. Choose the DC model on the navigation of the software. Input the current and voltage according to the certification. Please note that you need to use CC, constant current, mode. Click to turn on the standard lamp. You can also confirm the DC source whether output the same constant current as the one you input. Rotate the gamma angle 90 degrees clockwise or counterclockwise according to the actually situation. Make sure that the hole of the standard lamp holder faces the far detector. Turn off the other lighting inside of the darkroom. Close the door of the darkroom. The standard lamp will be stable after about 15 minutes. Click Photometric Calibration. Choose Illuminometer for near field. We use candela calibration but not lumen calibration. Input the candela here. Click Start. Then the test distance will change automatically according to your darkroom size. Then click Apply and OK. Then we calibrate the spectroradiometer. Choose colorimeter for near field. Rotate the gamma angle to 0 degree position. Rotate the gamma angle 90 degrees clockwise or counterclockwise according to the actually situation. Make sure that the hole of the standard lamp holder faces the optical fiber. Click Colorimeter Calibrate. Choose colorimeter for near field. Always check auto for the integration time. Click Sample. After successful sample, the Calibrate button will be available. Input the correct color temperature of the standard lamp, and click Calibrate. Click OK after successful calibration. Turn off the standard lamp after all the calibration. After the standard lamp cools, put it back to the box for safekeeping. According to the standards, car lights and traffic lights need to be tested by A alpha. Flood lights need to be tested by B beta. All the other lights need to be tested by C gamma. LSG-1890B and LSG-1800A goniophotometers can do B beta and C gamma test. Luminaires provides 2 clamps for C gamma test. The big cross clamp is used for big luminaires. The E27 holder is for bulbs. The assistant arm of the goniophotometer doesn't need to be installed back for C gamma test. Turn on the cross laser and make sure that the laser hit the correct direction. Install the clamp on the main arm of the goniophotometer. Choose Illuminometer for near field. Rotate the gamma angle 90 degrees clockwise or counterclockwise according to the actual situation. Make sure that the cross laser faces to the clamp. Install the luminaire to the clamp. Refer to the cross laser. Make sure that the cross laser hits the center of the luminous surface of the luminaire. And make the luminous surface of the luminaire parallel to the clamp. Rotate the gamma angle back to 0 degree position. Loose the lock and rotate it to make the luminous interface to the position of the vertical laser of the cross laser. Lock it again. Turn off the cross laser. Connect the power cord of the Luminaire to the red and blue terminals. Change the AC/DC switch on the cabinet to the correct position. Just keep this switch to outside position. Outside is 4-wire connection for the digital power meter. Choose the correct model of power source and input the correct voltage and current. Turn on the sample. Click Setup. Set warm-up parameters. Check warm-up if you need to preheat the sample before testing. Click Start Test. Choose Luminaire types. Indoor and roadway are C-gamma test. Flood is B-beta test. Choose unsymmetrical if no special requirements. If you choose symmetric functions, the Goniophotometer will not do a complete test, but used partial results to overwrite other parts. Test range for C angle is from 0 to 180. No need to change. If the luminaires are symmetrical in theory, you can use bigger step angle, such as 22.5, 30. Some luminaires are not symmetrical, such as roadway light, you need to use smaller step angle, such as 15, 10. In summary, the smaller step angles selected, the more accurate the test data will be, but the longer time it will take. Test range for gamma angle has two options: -90 to 90 and -180 to 180. For luminaires with a light angle less than 180 degrees, i.e. single-side luminaires, such as downlights and panel lights, you can select -90 to 90. Otherwise, such as bulbs, tubes, you need to select -180 to 180. Choose 1 degree for gamma step angle. If you choose bigger step angle, the candela distribution curve may be an uneven broken line. Choose the correct photo detector that you use if you have more than one photo detector. Choose the test speed. Usually, normal speed can be used. Scale is not important. You can choose fixed scale. Input the angle to be monitored during the preheating. Usually just use the 0 degree position. Select the uniformization option. Then all the C angles at 0 degree gamma angle candela values will be the same. You need to check uniformization to ensure that the exported IES files can be recognized by most of other lighting design software. If you want to remove the stray light beyond some angle, check Remove Stray Light and input the angle. Input the number of the light sources and the rated lumen of each lamp. If you don't know, just leave it blank. Input the luminous dimensions. Input the information of the sample. Input the temperature and the humidity of the darkroom. Click OK to enter the preheating interface. If you did not check warm-up, it will enter the testing surface directly. Only C-gamma needs the color distribution test according to the standard. Color distribution test need to be done after the candela distribution test. Click Start Test. The assistant arm needs to be installed back if you do B-beta test for floodlight. Then install the B-beta clamp to the goniophotometer. Make sure it's vertical. Click Type Convert to change the angle to B-beta. Click Rotary Actuator Control Panel. Rotate both B and beta angles to 0° position. Install the sample to the clamp, and the luminous surface should face the photodetector. To ensure that the luminous surface is in the center of goniophotometer, you also need to rotate the beta angle to make the cross laser hit the luminous interface. And adjust the position of the sample to make sure that the cross laser hits the center of the luminous surface. Use the same method to turn on the sample. Click to enter the test settings. Choose flood for Luminaire types. Then the test method will change to B-beta. Set the range of B and beta as -90 to 90. And no need to change. The principle of step angle for B is the same as C. The principle of step angle for beta is the same as gamma. All the other settings are the same as C gamma. Click OK to start the test. Here is a typical test report from the goniophotometer. Thanks for your watching.